So solve this equation in the real number system. 2 to the power of x plus 8 to the power of x equals 130. So when we have an exponential equation like this, I think the first thing is we need to make the 8 have the same base as the 2. Therefore, we could rewrite this as 2 to the power of x plus, and we know 8 could be expressed as 2 to the power of 3, and then we still have the x outside, equals 130. I'm just going to rewrite this as 2 to the power of x plus, I'm going to switch the 3 and the x, and we're okay to do that there, so 2 to the power of x cubed. Because we have an exponent outside the brackets, you multiply it into the exponent inside the bracket. So x times 3 will give you 3x, and 3 times x will give you 3x, equals 130. Of course, we cannot make this a base of 2, otherwise this would have been a lot easier. And therefore, I'm going to now move the 130 to the left side, rewrite this as 2 to the power of x cubed. I'm just going to rearrange this, plus 2 to the power of x minus 130 equals 0. Now I'm going to let y equal 2 to the power of x. And therefore, I could rewrite this equation here as y cubed plus y minus 130. Now this is a cubic function. So to be able to factor this, we're going to use the remainder theorem. And we're going to look at the possible factors of 130. What I could see obviously here is 1 cubed plus 1 minus 130 is not going to work. The negative 1 is not going to work. If I sub in 2 for the y, it's not going to give me 0. 3, that 3 doesn't go into the 130. So the next number that goes into 130 is 5. And I think 5 is going to work because 5 cubed is 125 plus 5 will give me 5 minus 130 will give me 0. So therefore, one of the factors here is 5. So what I'm going to do, I'm going to do synthetic division with 5 to figure out the rest of the equation. Now, the coefficients here are 1. We're going to have a y squared, so that's going to be 0. And 1 and negative 130. Bring the 1 down. 1 times 5 is 5. We write that there and we add 0 plus 5 is 5. Now 5 times 5 is 25. We add, we get 26. And 126 times 5 gives me positive 130. And when we add, we get 0. So the remainder here is 0. And that's why 5 is a factor. So now this equation factored into y minus 5. And from here we have y squared plus 5y plus 26 in brackets equals 0. So any of you who forget how to factor higher degree than a quadratic, cubic functions and so on, maybe just go and review that, but that's how we do it. Now, is this factorable? We cannot factor it. Can we use the quadratic equation? So what I'm going to do, I'm just going to find out the nature of roots, just in case we get that under the square root in the quadratic formula, if we get a negative number. So remember, under the square root is always b squared minus 4ac. That's what's under the square root in the quadratic formula. So b squared, that will be 5 squared minus 4 times a, which is 1, and times 26. And now it's obvious, this is going to be 25 minus a big number. So under the square root, we're going to have a negative number, and we cannot square root a negative number. And therefore, we're not going to get any other solutions in the real number system. Yes, we'll have a complex number, but not a real number. So this is the only So this is the only root for this equation. And now, from here we know y equals 5. And since y is 2 to the power of x, so now we know 2 to the power of x equals 5. To solve for x right now, we gotta log both sides. So log 2 to the power of x equals log 5. Logs allow us to bring the x down, so that's gonna become x log 2 equals log 5. Divide both sides by log 2, and therefore x equals log 5 over log 2. And we will leave the answer in exact values. And that's the answer for this. Thank you for watching. See you next time.